This video is how to do a proof part 3. I will link parts 1 and 2 in the description of this video. If you haven't seen those yet, I would highly recommend you go back and watch those. We're not really adding anything in this video. I'm really just going to be walking you through some additional proofs. Slightly more complicated than what we saw in part 1 and 2. Not too bad, but it will just give you a little bit more of an exposure to how to do a proof. As a reminder, here are all the rules of inference that we're working with. Modus ponens, modus tollens, simplification, conjunction, disjunctive syllogism, addition, hypothetical syllogism, and of course, our replacement rule, double negation. Also remember, here are 3 questions that you should ask yourself, or that you can ask yourself when you begin a proof, especially if you don't know how to get started. Number 1, what types of sentences do I have? 2, do I see my conclusion or anything like it in my assumptions? And 3, given my answers to 1 and 2, what rules am I likely to use? Here's our first proof. Everything before the turnstile inference bar, those are our assumptions, and this will be our conclusion. That's where we want to end up. First thing we do is we lay out our assumptions. We have a conditional and a conjunction. Do we see our conclusion or anything like it in our assumptions? Not really. Our conclusion is a conditional, and we have a bunch of conditionals in here. We have a conditional on line 1. A conditional is one of the conjuncts of the conjunction on line 2. And so that should alert us that we might end up using the rule of hypothetical syllogism, because that's the one rule where we start with a bunch of conditionals and then end up with one. So that's just something to keep in mind. The first thing we probably want to do is we have a conjunction here. It's a good bet that we're going to have to split them up with the rule of simplification. So on line 3 we can get P. On line 4 we can get if T then R. Both of those by the rule of simplification from line 2. But now look what we can do with line 1 and 3. 1 is if P or Q, then if R, then S. That's a conditional, and we know that if we had the antecedent, we could get the consequent, and that would be one more helpful thing to get, as we'll see moving forward. We don't have the antecedent yet on line 3, but we have what it takes to get it. Remember, if P is true, P or anything else is also true, so we can infer P or Q by the rule of addition from line 3. But now, with that, with lines 1 and 5, we are allowed to infer if R then S. We have a conditional and the antecedent, so we can infer the consequent. But now if you look at 4 and 6, we have if T then R and if R then S. So we are, in fact, going to use hypothetical syllogism like we sort of predicted. On line 7, we get if T then S, and that's exactly where we want it to go. So we are done. Okay, here's a second proof for us. We're only given P, and we're supposed to end up with this whole long thing over here. So we lay out our assumption. How in the world are we going to get all of this? It's pretty simple. Maybe you already see it. If you don't, that's all right. But all we have to do is add it by the rule of addition. If P is true, P or anything else is true, even this big long thing. This is a valid inference because of the rule of addition from line 1. And this is just a 2-line proof, not including the assumption. It's a 1-step proof, and we're done. Here is a third proof for us to try. This one has got a lot of stuff going on. It might take us a little bit more than our last proof. Let's lay out our assumptions. There they are. We have a conditional, and then just a simple sentence. Do we see our conclusion or anything like it in our assumptions? Again, sort of, not really. We're trying to end up with S and P, and we have not S as the antecedent of a conditional, and not P as the antecedent of a conditional. That should maybe raise the red flag of modus tollens. Maybe we're going to end up using that twice. We'll see what happens. But our strategy should probably be something like this. Try to get S and try to get P independently of one another. And if you do, you can just sort of put them together, so to speak, using the rule of conjunction. So we will try to do that. Notice what we can do with Q. We can add R by the rule of addition. Why would we want to do that? Well, if you look at 1 and 4, you're really close to being able to use modus tollens like we sort of set out to do, or like we sort of mentioned. All we have to do is add the double negation. If Q or R is true, then by the rule of double negation, not Q or R is also true. Now, with lines 1 and 5, we have a conditional and the negation of the consequent. The consequent is not Q or R, and on 5 we have not Q or R. So we're allowed to infer the negation of the antecedent, which is not P, on line 6, from the rule of modus tollens, 1 and 5. And then we can just get P, again, using double negation. Now we have half of our conjunction over here. Now we just have to get S. And you might already see it. Again, if you don't, that's all right. But we can pretty much do that same thing. We can use that same strategy that we just used to get P. Look, we have P on line 7. We can get P or T by the rule of addition. Now look at 2 and 8. We're really close, again, to being able to use modus tollens. We just got to use double negation to get not P or T. Moving over here to step 10. That gets us not S. If you look at 2 and 9, again, you have a conditional and the negation of the consequent. So you get the negation of the antecedent. That allows us to get S by the rule of double negation. But like we sort of set out to do, look at 11 and 7. We can just quote-unquote put those together. S and P, conjunction of 7 and 11. And that is the conclusion of the sequence, so we're done. Okay, here's another example. Lay out our assumptions. We have a conditional, and a simple sentence, and we're trying to end up with a simple sentence. Notice that our simple sentence is Q, and Q is found in here. Q is a disjunct of a disjunction, and that disjunction is the consequent of a conditional. It's a mouthful, but it might lead you to think, maybe we're going to end up using modus ponens and then disjunctive syllogism. But if you look at 1, 2, and 3, we can actually use modus ponens twice. Look at 1 and 3. You have a conditional and the antecedent, so you get the consequent. But you can also do that with 2 and 3 to get not R. So now you have Q or R and not R. And then on 6, you can get Q from disjunctive syllogism from 4 and 5. Okay, here's another example. We'll lay out our assumptions. We've got a bunch of them. We have a conditional simple sentence, conditional simple sentence, and we're trying to end up with a simple sentence, S. And S is the consequent of a conditional. That should tell us that we might use modus ponens. If you notice on 1, we do have a conditional. The antecedent is P and Q. We don't have the antecedent. We don't have P and Q. But we do have P and we do have Q. So we can get P and Q. Conjunction of 2 and 4. Now with 1 and 5, we can get R by modus ponens. And we're really close to getting S. S is the consequent of a conditional again. And if only we can get R and P, that would be the antecedent. We could use modus ponens one more time. Now we have R, and we already had P. So we can get R and P by conjunction of 2 and 6. And that allows us to use modus ponens again to get S from 3 and 7. Here is another example. We will list out our assumptions. We have a disjunction, we have a conjunction, and then we have a conditional. And we're trying to end up with just S. Given our answers to those two questions, what rules are we likely to use? Well, if you look over here, S is the consequent of a conditional. We have a rule where you end up with the consequent of a conditional, modus ponens. So maybe we should be on the search for not R. If we got not R, then we could use that to get S. How do we get not R? That's what we're trying to do. Just to start out, notice that on line 2, we have a conjunction, so we can simplify that. On line 4, we get P, simplification from 2. On line 5, we get if R, then Q, simplification from 2. And now we're on the search for not R. How do we get not R? We're trying to get not R, and we see that R is the antecedent of a conditional. If we get not Q, then we could get not R from the rule of modus tollens. How do we get not Q? Look at 1 and 4. We almost have what we need to use disjunctive syllogism to get not Q. Remember, the disjunctive syllogism says, if you have a disjunction and the negation of one of the disjuncts, you can infer the other disjunct. We don't have the negation of not P, but we have what it takes to get it. If P is true, on line 6, we can get not P by the rule of double negation. Now, we can use disjunctive syllogism to get not Q, because on 1, we have a disjunction. On 7, we have the negation of one of the disjuncts. We have not P, and one of the disjuncts is not P. So we're allowed to infer the other disjunct, not Q. But now we can use 5 and 7 with the rule of modus tollens to get not R. We have a conditional and the negation of the consequent, so we get the negation of the antecedent. But with 3 and 8, now we can just get S with the rule of modus ponens, and we are done. Here are just a few more examples that you can use for practice. If you would like, you could pause the video and work through these, and I will reveal the answers. Lines 1 through 3 are our assumptions. On line 4, we use the rule of conjunction with 1 and 3 to get X and Z. On line 5, we do a double negation of 4. We arrive at 6 because of modus tollens. With lines 2 and 5, you have a conditional and the negation of the consequent, so you're allowed to infer the negation of the antecedent. And then on line 7, we just combine lines 1 and 6 with the rule of conjunction. And that completes this proof. Here's another example. Again, you can pause the video if you'd like to try it out on your own. And here is the answer. Lines 1 through 3 are our assumptions. On 4, we get that as a result of hypothetical syllogism for lines 1 and 3. If X then Y and if Y then A, you're allowed to infer if X then A. We can do a double negation of if X then A on line 5. If X then A is true, then not if X then A is also true. On 6, that's a result of modus tollens. On 2, you have a conditional. On 6, you have the negation of the consequent. So on 6, you get the negation of the antecedent. On 7, you again do a double negation of 6. And then 8 is a result of hypothetical syllogism 1 and 7. On 7, you have if Z then X. And on 1, you have if X then Y. So you're allowed to infer if Z, then Y. Again, hypothetical syllogism 1 and 7. Here's one more example. Lines 1 and 2 are our assumptions. We simplify out 3 and 4 from line 2. 5 is hypothetical syllogism from 3 and 4. If X then Y, if Y then Z, therefore if X then Z. Again, that double negation. Now look at 1 and 6. On 1, you have disjunction. On 6, you have a negation of one of the disjuncts. So on 7, you're allowed to infer the other disjunct. And then 8 is a result of hypothetical syllogism 5 and 7. You have if X then Z, and if Z then A, so you're allowed to infer if X then A. These are just a few more examples. Hopefully this was helpful for you. If you have to watch these videos more than once, that's okay.